Good morning, and welcome to this ARCHER2 course, which is aimed at software package users, or people who will primarily be using software packages on the system rather than compiling their own code. My name is Andy Turner. I am one of the members of the ARCHER2 CSE team. CSE here stands for Computational Science and Engineering. Our job really is to help users get the most out of the system. So support them importing the applications, getting performance, answer any questions they have, also provide training and the technical documentation, and all that sort of side of ARCHER2. So I just wanted to, before we start, I would say, thank you for coming along and taking the time to come along. Because obviously it's a bit different. Of course, it's online all the time now, but we've sort of got used to that a bit more now. And also to say, as I mentioned just a moment ago, we are recording these sessions. So what we do with the recordings is we post-process them and then put them up on the ARCHER2 website. Part of that post-processing is to remove any personal information or things that could identify people from it. So we do work quite carefully to try and do that. So please, as we go through, feel free to stop me, ask questions, ask for clarifications on anything we're doing, and anything that doesn't make sense or you need clarified a bit more. This lesson is really aimed at people who've already used other HPC systems, and as I mentioned, are generally using pre-installed software or have access to binaries for software. I mean, obviously there's a spectrum of use cases here, and it doesn't mean you'll never be compiling or developing your own software at all on the system, but the primary aim of this course is for people who, it doesn't really cover compilation application development at all on the system. So what we are going to cover is have a look a bit what ARCHER2 actually is and what it consists of, and what that means for you as a user of the system. Accessing ARCHER2, make sure we get people that can log on, and all those sorts of things. What the software environment looks like, writing job submission scripts, and some of the bits and pieces at the end about being a good citizen, and looking at your historical use and potentially where you can go after this course if you're feeling you need more support and training and things like that. So the schedule here is sort of rough, and I'm not going to stick to it slavishly. Sorry, I should also say my camera's broken for some reason with Collaborate that I don't understand why, which is why you can't see me. So apologies for that. So the schedule is, I'll take it in mostly as a guide only, with the exception that I will do lunch at the hour from 12:45 to 1:45, come what may, whether we're in the middle of an episode or anything like that. We'll keep the lunch fixed, and it will be the hour, and we'll stop exactly at that time to help you plan and organize your day a bit. But the rest of it, we'll go at a pace that suits you, and what's the best for the people on the course. So I'm not going to be worried about dashing through stuff or catching up or things like that. We want to make it as useful as possible to you. So please let me know if I'm going too fast, if I'm going too slow, or if you have any questions or want clarifications on anything as we go through, and we'll work our way through the material that way. We've got plenty of time set aside for this course, so there's no need to rush. I don't think in any sort of real way. So apart from that, the sort of logistical stuff, one thing I do want to point out is that we do have a code of conduct for ARCHER2, that covers all the interactions around the ARCHER2 service, actually, not just training, but also any other events we run, interactions on the service desk, interactions between users themselves in whatever way they can on the system, which essentially means we should treat everybody with respect, being respectful and welcoming for different people, and make sure we use inclusive language for people and show courtesy and just be kind. Fundamentally, it's be kind to each other and understanding about each other, and that creates the best environment we've found for both learning and for the service in general. So if you run into any problems and you think somebody is violating this code of conduct, including myself or the people helping us on the course, then you can report it by completing this form. If it's not me, then you can also send me a private message in the chat, and we'll do our best to investigate and do something about it for you. We can't, we can't promise essentially what action we'll take, but we do promise to take everything seriously and look into it properly. And the way this course is going to work is it's rather than a set of slides and exercises, it uses this sort of carpentries approach. I don't know if you've been on a carpentries course before or not, but the idea is we all work together through the material. Now, because this is a sort of course where I'm going to be giving you a lot of information about ARCHER2. Actually, there's quite a lot more of me talking and presenting information than on a typical carpentries course, but there are a couple of sessions, particularly when we look at jobs and writing job scripts, where we'll be asking you to, I'll do something and then I'll make sure that you people, your attendees have done it as well. And so you've had a chance to actually use the system and practice some of the skills here. You could use, to actually follow along, you have to log into ARCHER2. To do this, you can either use an account that you would have received instructions on how to sign up for an account through this course, which you can use quite happily, or excuse me, if you have an ARCHER2 account through a different project, you can feel free to use that for the course as well. It'll work just as well. We won't be using up any budget really in this course, and the type of jobs we'll be running. We'll be running very, very small, very short jobs, so it won't impact your budget at all. So you can easily use an existing account on the system. If you have requested an account through the course, and you don't or have another ARCHER2 account for a project, then the account does not go away at the end of today. It stays around for about at least another 3 or 4 weeks to allow you to carry on practicing using the system and follow up on the things you've learned in the course to try and do things. And if you have any questions after the course, feel free to send them into the ARCHER2 service desk. You can mention that you're on this course, and then the questions get pointed in the right direction. And we're happy to continue supporting people after the course has gone on, because we're aware that the learning doesn't just consist of today. You have to have time to absorb the information and actually try to do something with it. As well as myself on the course, we've got a couple of helpers here to help you. So there's Juan and Kevin. So if you have questions or you run into problems where it's useful to step away from the main room, there's a couple of breakout rooms that they may take you into, where you can share screen with them and look at if you're running into problems where you need a bit more of an in-depth look, they'll be able to help you there. But again, if you need help, either say something in the chat, put your hand up. There's a hand up functionality in the Collaborate interface, which you can use as well, or you can just shout, switch your microphone on and shout at me, and I'll stop and listen. Finally, there's this shared collaborative document which is called the Etherpad, which we've got a link to. Actually, we should probably put the link in the chat again, because a couple of people have joined since the links were last there, and I don't think you see links that were in the chat beforehand. Thank you, Kevin. So that's the link to the Etherpad. There's also a link to the course materials, which is on the main ARCHER2 website for the page for this course, or we'll put it in the link and it's in the Etherpad as well, and we can put it in the chat again here. There we go. Thanks, Kevin. As with the recordings, we take a copy of the stuff in the Etherpad, we remove any personal information, and then make it available for the course. And finally, something about feedback. So I've already mentioned that feedback during the course is great, to tell me to go slower, go faster, to clarify points. I'm happy to take that. You'll also get at the end of the course an opportunity to provide more formal feedback, and this is really important to us. Things you liked, things you didn't like, things that could have been better, things you'd like more of, things you'd like less of. They're all really important to us, because what we really want to do is make this as useful as possible to users. Without that feedback, we can't keep improving the courses to make them better for users. So please do take the time to fill that out and provide your thoughts, because that is really, really valuable to us. So given that, I think we'll get on to the actual material. Please stop me if you have if anything's not clear, and I'm happy to look at it. So I'm happy to look at that or answer any questions. So in this first section, we're going to actually just make sure we can connect to ARCHER2, and we're going to talk a bit about data transfer as well, which is always one of the challenging things we use in a remote HPC system, is how you move the data about. But essentially, one of the key aspects of this lesson is to make sure that everybody can log in, and that the and that we've all got an active terminal. So typically on ARCHER2, you connect via SSH. Depending on what OS you're using for your client machine. In my case, I'm on a laptop. You can see it's a Mac laptop, so it comes with SSH built in. But for Windows, you may need to add a program such as MobileX PuTTY or some such thing to be able to access the system via SSH. If you're using Linux, then again SSH is built in. One of the pre-setup parts of the course was hopefully to get an account and to get the password and get logged in. But I'm going to recap that process just in case some people haven't had a chance to do that yet as we go through the session. So one thing to note is that when you log into ARCHER2, you need to use both a password and a passphrase protected SSH key pair. So there are two factors involved in accessing ARCHER2. And this is becoming more and more common in HPC systems, is that you need multi-factors to access the system. I mean, and often one factor is password and the other factor is some sort of time limited key, like you might use to log into your internet banking or something like that. But at the moment on ARCHER2, it's password and an SSH key pair. So when you first get your ARCHER2 account, we'll see this in a minute. I'll show you exactly what this means. You get a single-use password from our web interface, which is called the safe. And the first time you log in, you'll be asked to change that password. Okay. And for this, you obviously have to pick a password that fits in with the ARCHER2 password policy. Now, the idea we've tried to go through with the password policy on ARCHER2 is to try to allow people to use simple things or things that just involve alphanumeric characters, because trying to remember things with lots of different special characters can be challenging. But we're also aware that people often have passwords with special characters and things like that. So for every sort of different type of character you include, you get some sort of credit, which means you can have a shorter password. So what that means is you could have a short password, which is complicated in terms of the type of characters it has in, uppercase, lowercase, special characters, numbers, so on and so forth. Or you can have a long password, which doesn't have any special characters in. Okay, so there's a short exercise here which can be fun in person but doesn't work as well online. So I'll just go through the answers here. So it talks about which of these passwords would be a good valid choice according to the ARCHER2 password policy. So there's a few ones here. So the first one, obviously, hopefully everybody can see, is not a very good choice, right? It's both short and it's made up of obvious words. The second one is a much better choice, right? It's quite long, and although rainbow llamas jumping are probably more common in terms of word combinations than they used to be nowadays, it's still a pretty random combination of words. So it's likely that that one is a reasonable password choice. Maybe not the best, as it's now published publicly on the web as part of this course. So probably not a good choice just for that reason. But in general, that's the right sort of idea. Number 3 there is just a random selection of various different types of characters. It's short, but it does have a lot of different characters in. There's no repeated characters or anything like that, so that's fine. Though it may be difficult to remember to type, though obviously you can use things like password managers to get around those sort of things. And number 4, while meets criteria, is for the same reason we've looked at rainbow llama jumping, which is published publicly. That one is the classic example from a webcomic known as XKCD. So is used as the sort of canonical example when discussing password strength now. So wouldn't be allowed because it's just so well known and well supported. It's the equivalent of having your password says password, at least in some sense. So when you pick your ARCHER2 password, it's up to you in the sense of what type of password you go for. Personally, myself, I typically go for the sort of longer, but with no special characters option, which means I sometimes mistype it wrong if I get out of rhythm, but means I don't have to think hard. It's easy for me to remember, even though it's a long password. but each person has their own personal choice. So as well as the password, which we've chatted about, I mentioned that you also need an SSH keeper. I'm not going through go through in this section unless somebody really wants me to about information on how to generate a keeper. It is slightly different depending on what SSH client you use. In general, if you use Mac and Linux, it's one route, and sometimes in Windows you generate it in a different way, but it depends which sort of SSH client you use in Windows. And there is more information at this link about how you can go about generating an SSH keeper if you haven't already. So what we're going to try and do now is actually log into ARCHER2. So I'm going to go. I've got a new account in this course project. I haven't picked up the initial password for it yet, so I'm going to do that, and then I'm going to log in for the first time. So I'm going to go to the safe website. So let's go to the ARCHER2 website, and there's a link to the safe up here at the top right. It's very hard to read on my screen. It's quite tiny there, but it says log into EPCC safe. So I'm going to do that. I'm already logged in because I was logged in earlier today. And you get this interface. I might have slightly more menu items than you because I'm one of the service. I'm involved with the service, so I have some more extra rights in the safe. But you've got a list of login accounts. Most people's login accounts are quite small. I've got lots and lots of them for various reasons. But I've got one associated to this project, which is this one here, which is, sorry, let me zoom in a bit there because that's quite hard to read. So I've made it a little bit bigger. It makes it a bit funny with the menus, but you can see here. So this is my username for this account. And it's on ARCHER2, it's in this project, blah, 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 blah. And it's got a couple of SSH, or it's got, for some reason, 2 copies of the same SSH key associated with it. I don't know, I must have put it in twice for some reason that I can't remember back in the past. But when I'm logging in for the first time, I can get my initial login account password by using the view login account password. And it gives you this one-shot password from the safe. Now, the easiest way to use this, there we go, thank you, is just to copy and paste it. So now I'm going to SSH and give it the path to my key because it's in a non-standard location. So I've got an idea. That's the name of my private part of my key. I give it my username, TA045 at login.archer2.ac.uk. Okay. Okay, so that has to be my password. Actually, it may well have asked me for my key passphrase at some point. I have an SSH agent running which already has that key in, which is why I won't have to enter my key passphrase. But you will be asked for your key passphrase at some point in this login process as well. So I'm going to paste in that initial password I got from the safe. You'll see that no characters appear. There's not even stars or dots or anything like that. And that doesn't mean it hasn't typed. It's just the way passwords work on the command line. And the first thing it says to me is, that's a one-shot password. You've got to change it straight away. And here, LDAP password is synonymous with just login password, ARCHER2. So it's asking me to enter the same password again. So this is my one-shot password again. So I'm going to just paste it in again. Okay, and then it says, give me a new password for this account that you want to use. So I'm going to type this. Again, you'll see nothing appears on the screen because when I type passwords here, you don't get dots or stars or anything like that. There's a security feature. So I've typed it once and it's going to ask me to type it again. And so, okay, so what I made a mistake there is I typed the password. I didn't get the passwords right. Didn't get them the same twice. So I'm going to try that again. Okay, so I did get it right that time. Fine. And then I'm logged into ARCHER2. And the banner's a bit mucked up because I've zoomed in my terminal so much that everybody can read it. Okay, so once we're in, then we could potentially start doing work. But obviously, often before we start work, people, you're going to need, you almost always need to transfer some data onto the system. Even if it's just basic input files, there are some cases where the input files are very small and you might generate them on the system yourself, so there's no need to transfer data up. But even then, once you've finished doing your jobs, your modeling, your simulation, you'll almost always have some data you need to transfer out of the system. So at the moment, there's essentially one way to transfer data out, which is using SCP or rsync sitting on top of SCP. SCP works well if you're transferring small or medium amounts of data. It's quite, the syntax is quite simple. It's quite quick and easy. Rsync tends to work better if you have to keep some data sets in sync between two locations quite often, or actually works better when your data sets are a little bit larger, because it can do things like it can partially transfer data, and when the data transfer stops, you can pick up where you left off. Okay, so I think it does have some advantages in that sense, but the syntax is a little bit more complex to get the right options. So typically, if I'm transferring one or two files or a directory or something like that, I'll use SCP as long as it's not too much data or too many files. Otherwise, if it's something I think is going to take a long time and there's a fair chance of the network connection dropping during the process, then I'll switch to using rsync. But I always have to go and look at the manual page for rsync because I can never remember the options off the top of my head. So that's why I always end up using SCP. There's a lot more information on this, on these sort of things and the options to use in the data transfer section of the user guide. So you can see that. But I'm going to cover just here, rather than talk about the technical stuff and get people transferring data, I'm going to mention more some best practices, some distillation of our experience of helping users with various national services over time. So the main things that I think we all get across is, you probably don't want to transfer all the data, right? So understanding what your data set looks like and thinking about it a bit ahead of time, what your usage of data is going to look like on the system, is actually a very valuable thing to do. Even just spend an hour or something thinking about what data you're going to generate, which data has to be transferred, know what data you have, which is critical and would be really difficult to regenerate if it was lost, or would be really painful to regenerate if it's lost. So it should be kept in a secure location. Which data needs to be in different locations to analyze potentially, because maybe the tools that you need to do the analysis on is not Archer, or doing graphical analysis on ARCHER2 itself can be a little bit challenging. So sometimes it helps to have the data locally if it's a volume you can hold locally on your workstation or laptop, so you can do some visual analysis there. Which data, conversely, actually is large but isn't too much of a problem to regenerate. So actually maybe it's not worth going to all the efforts of transferring it out, because actually regenerating the data is quite simple and not too problematic. And it says here about creating a brief data management plan. That is not like a big multi-page document about which data goes where, though that might be the case for a very complex project with lots of partners who have to share data and things like that. Even if it's just for a single user, it's just for your research project, your PhD thesis, or the thing you're working on at the moment, having a small description of and a plan about which data is going to be transferred, which data doesn't need to be transferred, which data is critical, is definitely a useful thing to spend some time thinking about before you start generating it. And understanding where it should live, even on ARCHER2. The ARCHER2 home file system is lower capacity, not available on the compute nodes, but it is backed up. Whereas the work file system, for example, is high capacity, high performance generally, but isn't backed up at all. So there's the potential for a hardware failure to lose any data that you have at work. So if you have a really critical data and it's living on this work file system, then maybe it's it really is worth thinking about how you periodically take a copy of it somewhere else where you have more, I guess, robust or more protected storage, if that data is really, really important to you and your project. Sends a really obvious point: minimize the amount of data you're transferring. Transferring large amounts of data is costly both in terms of actual, potentially in actual time, but generally more costly in terms of researcher time. You know, setting up, managing transfers of large data, you know, and when the network interface dies, restarting them, it's a big overhead and it's a big hassle, you know. So, you know, actually thinking about what data you need to transfer and why, rather than trying to do everything, can save you a lot of time, of your time, babysitting transfers. Minimizing the number of files you're transferring. So each individual file, the challenge with individual files is each individual file, there's a static overhead in the data transfer. So for every file, no matter how big or small the file is, there's essentially a startup cost for the start to transfer, establish the connection, you know, exchange security credentials, check that the file exists on that end, check that you can write to the location on the other end. You know, there's all these steps that have to be undertaken, and that happens for every single file. For if you say your SCP 1,000 files in, that's 1,000 times that static overhead. So even if it's quite quick on the order of seconds, you know, suddenly transferring even a small amount of data, if it's split into a large amount of files, becomes problematic and takes a large amount of time. So, you know, we'll talk in a moment about combining files in an archive into a single file can make it much more efficient, as long as you have the disk space to be able to do that. You know, particularly in that case where you have lots of files, but the actual data volume is quite small. Creating an archive of a single file of all that data in is usually a better way to go before you start to transfer it. And does compression help or hinder? So most tools that have an option to use compression, so both data transfer tools such as rsync, and also tools we'll look at in a moment about creating archives and combining files. And a lot of the time you'll see the examples you'll see online about creating such archives or using such tools always enable compression. Always do, just about. But that's not always the best thing to do, because the reason you do it is to reduce data volume, which is great. But if the data transfer bandwidth between the two sides you're transferring to and your data volume's large, and you've got enough storage space on each end, actually the bottleneck can suddenly not be the actual data transfer speed between the two locations, because you've got a very wide connection. Say you're transferring from ARCHER2, which has very fast connection to the network, to another HPC site or a data facility that has fast connections. Say, and there's a facility called Jasmine, which stores climate data. Then often compression doesn't help you, because what you end up doing is bottlenecking on the performance of the processor doing the compression rather than the bandwidth of the disks or the network connection. Okay, so you know it is worth actually testing if compression helps or hinder. And yeah, you can test that sort of thing. I mean, generally, if you're transferring to your laptop, say over Wi-Fi or something where there's a Wi-Fi involved in the connection somewhere, then probably network bandwidth is going to be a limiting factor. So you probably do want compression if you can manage it. But if you're transferring to somewhere that's directly connected to the academic network, Janet, and then probably compression is not going to help you, or may even bottleneck you. And finally, when transferring using SCP or rsync, which uses SCP under the hood to transfer the data, is going to be encrypted, and that can cost a bit as well. The default encryption methods used by SCP and things like that are chosen for their robustness in terms of encryption rather than their speed of encryption. If you switch to a different cipher, which you can do, there's command line options to SCP and to SCP via rsync. To do this, you can get a huge performance improvement. And you know, generally, when you're transferring scientific data, the encryption strength isn't the key characteristic that you're interested in. So if you switch to a cipher that looks like sort of like this AES 128 CTR cipher, then you get it much faster, because most modern processors have hardware implementations of some encryption ciphers, such as these ones that are used relatively often. So you can get a big speed up by changing the encryption algorithm you're using. And so there's a small exercise here, again, which probably works better in person than online. which asks you to go into the documentation above and find the command you'd use to create an uncompressed zip archive of all data in a particular directory on the system. I'm not going to ask you to go away and do this because we'll just be saying twiddling our thumbs while you read the documentation, and that's something you could do do in your own free time. So, if you're interested in the options and how to archive files, then I'm happy to come back and discuss more of that. If you want to have a go at this exercise at some point later on and then ask me questions about it, that's fine. I won't show you the solution right now, but we can definitely talk about it. What it's trying to do is show you, that trying to get you used to looking for options such as the no compression option, which is obviously a key one. And the other thing it's trying to get home here is that before you delete original copies of data after you create an archive file, you should verify that it's not corrupt and that actually you have a valid copy of the data. Excuse me, because if you create an archive file and then delete your data without checking its integrity, you may have just lost all your data. So you do have to be careful when creating these archives. And obviously, one of the challenges here is, if you're limited on disk space and you're trying to create a very large archive, that might be a problem. That could be problematic for you. So you may have to batch up your data depending on how much disk overhead, because you obviously have to have, especially when you're doing no compression, you're going to have to be able to hold 2 full copies of the data of whichever data you're archiving in your quota at any one time. So I think we got most people logged in. I haven't heard any from Zongzi in the chat or online whether they managed to get logged in or not. Please do drop us a line if you're struggling. Otherwise, I will assume for the rest of the course that you've managed to log in, and we'll be on to do the work of the course. I assume that everybody's able to access ARCHER2 and follow along. So please do let us know. We've got the break coming up in a moment to check that out for you if you're struggling. So in this section, it says the key points here is that the login address is this, so that's what you use to log in. That's fine. There's a password policy. I'm not sure how much of that's a key point at the moment, but there's a couple of different algorithms for transferring. There's a couple of different ways to be rsync and SCP. Excuse me. There is also we are working to install the Globus toolkit on the system, so people can do parallel file transfers using grid FTP. That's a bit more involved and beyond the scope of this course. If you're interested in that sort of tool, which is used for very large-scale data transfers between data centers, then please say, and I'm happy to talk a bit about that with you as well. But I think the key point is, I would take it away from the data here anyway, is before you start doing stuff, at least take a small amount of time to think about your data and what data you're generating and what data you need to transfer, so you've got a good plan, which data is critical, so you're not surprised if you end up losing that due to a hardware failure, or you've got a copy of it somewhere which is well backed up and well looked after because it's the critical data for you.